Bismillahirrahmanirrahim. Today we will start new topic, probability. Definition of probability is the chance that something will happen. This is the definition of probability. Probability is the chance that something will happen. Chance of occurrence of something. There are essentially three approaches to the probability. First approach is called classical approach. If an experiment can result in an equally likely, mutually exclusive outcomes. Equally likely means equal chance of occurrence. Mutually exclusive means if the A intersection B of two events is equal to null set is called mutually exclusive event. No common element. So all possible outcomes in any experiment is called sample space S. And the number of observation in sample space or member of the sample space is represented by n. This is number of outcomes of this sample space. How many members in this sample space? For example, if you throw a coin, you have used this example in definition of the sample space and event. If you throw or toss a coin 2 times or 2 coins 1 time, total number of outcomes are 4, HH, HT, TH and TT. So this value, total number of outcomes is represented by small n. R of which are favorable to the occurrence of some event A. Occurrence of event A. You know that the event is the subset or part of the sample space, and we always find the probability of event. In same example, suppose the event is exactly one had occur. So the favorable outcomes are HT, TH, one had occur. There are 2. So this 2 is small r. Because in formula of the probability we use the number of outcomes. How many outcomes in sample space, how many outcomes in event. We write the number of outcomes in numerator and number of outcome of sample space in denominator. So formula, then the probability that event A will occur is defined as the probability of an event is equal to number of outcomes where the event occur. Number of outcomes where the event occurs. This is the event occurs. Divided by total or possible outcomes, and this represented by small r, possible by small n. Okay, you can write here favorable outcomes or possible outcome in denominator. Favorable outcome is in favor of the event because we find the probability of event always from the total possible. So the formula of the probability of in classical approach, probability of A is equal to R upon N. And why this is called classical approach? Because it's the classical formula of the probability, and we can draw numerator term and denominator term, outcome of the event divided by outcome of the sample space or possible outcome. Out of total, how many? Is a classical approach. So you have used this example in the definition of sample space and event. If you throw a coin 2 times, number of outcomes are 4, event is exactly one had occur, the favorable outcome will be 2. So the probability exactly one had occur will be 2 divided by 4.5. So this approach is called classical approach. In this example, in this experiment, we can draw all possible outcomes and outcome of the events, any event. Okay. Now second approach Relative frequency approach, you have already calculated the relative frequency in the graph, bar graph and pie chart, and relative frequency is also called the probability, corresponding class probability or group. So the proportion of time means frequency, that an event occurs in the long run when conditions are stable. Long run means large number of trials. If you throw a coin 1 time, 2 time, 3 time, there are only 2 possible outcomes, head or tail. If you throw a dice 1 time, 2 time, 10 time, outcome may be 1, 2, 3, 4, 5, 6. And how many times is called frequency, or the observed relative frequency of an event in a large number of trials. If an event A occurs f time, number of times, f is called frequency, then the probability of A event is defined as the limit of the relative frequency, f upon n. What is the f upon n? This is the formula of the relative frequency, or is also called probability. The previous formula, this formula is same. In this we use R. R is the number of outcome of event. In relative frequency approach, we use here number of frequency values of the corresponding class, and this is the same as classical approach. So f upon n of the occurrence of A. So notation is different but formula is same, property of A, and this limit n tends to infinity indicate large number of trials. If the observations are large, you know that then we convert into frequency distribution table, same as here. If the number of trials are large, we convert into table in the group and represent in terms of frequency and total frequency. So if you throw a coin 3 times, you have solved this example in previous video. If you throw a coin 3 times, total number of outcomes are 8. You have done this, and the event is head occur. What is the possible values of occurrence of head? Maybe 0 head, maybe 1 head in 3, maybe 2 heads in 3 outcome or 3 out elements of the member of the set, and 3 heads 1 time. So 0 head 1 time, 1 head 3 times, 2 heads 3 times, and 3 head 1 time. So possible values of head represented by x, because this is the variable changeable. In event we use the capital alphabet A, B, C, D and so on, how many outcome of the event. But x is the all possible values of the head, maybe 0 head, maybe 1, maybe 2, maybe 3 heads. And how many times 0 head? 1 time. So this is the frequency. 1 head occur 3 times, 2 heads occur 3 times, 3 heads occur 1 time. So we write the possible values in this column with value of the x, and this is the frequency. Number of observation lies in a particular group or class. Same as the frequency distribution is called frequency. If you divide the frequency by total number of outcomes, 1 plus 3 plus 3 plus 1 is equal to 8. Total outcomes 1 upon 8 is the relative frequency or probability. 3 upon 8, 3 upon 8, 1 upon 8. So you can say if we throw a coin 3 times, the probability of occurrence of 0 head is 1 upon 8. Probability of 1 head occur 3 upon 8. Probability of 2 heads occur 3 upon 8. Probability of 3 heads occur 1 upon 8. So this approach is also called the relative frequency approach, and this is the same as the classical approach, but we use the frequency for probability. And next approach is the axiomatic approach. Axiomatic approach is the combination of the first and second. You know that in previous example, the result of probability is the numerical value, and probability lies between 0 and 1 always, cannot be more than 1 and less than 0, cannot be negative. So from first and second approach, you can say this is the axiomatic approach. Axiomatic approach means this is the assumption, axioms. In this approach, the property that an an event, this is not an event A will occur is a number, and this number satisfies the following axioms. Number first, for every event A, property of A will be greater than or is equal to 0. Property of sample space is equal to 1 always. In this previous example, property of this is equal to 1 upon 8, probability of this is equal to 1 upon 8, probability of this will be equal to 1 upon 8, because this one time occur out of 8. So if you add 1 upon 8 8 times, will be 8 upon 8 equal to 1. And first example, property of this 1 upon 4, 1 upon 4, 1 upon 4, 1 upon 4. If you add 1 upon 4 4 times, will be equal to 4 upon 4 equal to 1. So the probability of sample space is always equal to 1. So from first and second, you can conclude that for every event A, the property lies between 0 and 1, that is property of A greater than or equal to 0 and less than or equal to 1. Now some probability laws, we will use these laws in numerical. First, if A and B are any two events belonging to the sample space S, you know that the event is a part of the sample space. Then you know that the property of A union B is equal to the member of the set A, member of the set B. If any member occur two times, we write only one time. So same as here in probability, if you calculate the probability of A union B, this part and this dark color and this light color, this plus will be equal to union. But in probability, if you calculate the probability of A plus probability of B, probability of A plus probability of B, this area occurs two times. This area occurs two times. First time in probability of A, second time in probability of B. So we subtract one time probability of A intersection B, same as the union. You know that if any member is common, we write only one time. Second, two events A and B are mutually exclusive, means there is no common, property of A intersection B will be equal to 0, so you will obtain this formula. And third law, if A and A dash read as A complement are complementary event, then property of A complement is equal to 1 minus probability of A. You know that in mathematics U is the universal set and complement is equal to U minus A. Same as in statistics, instead of U we are using here S sample space. Is the universal set, this will be S. So same as the numbers or values or outcome, A complement is equal to S minus A, the probability of A complement will be equal to probability of S minus probability of A, and probability of S is equal to 1, so this will be 1 minus probability of A. Okay, now we will solve one numerical. A fair dice is rolled once, thrown once. You win if the outcome is either even or divisible by 3. What is the probability of winning the game? The question is find the probability of winning the game. When you will win the game, if either even number occur or divisible by 3, if you throw a dice once. So you know that if you throw a dice once, sample space are 1, 2, 3, 4, 5, 6. For probability, we will use the classical formula, number of favorable outcomes divided by possible outcomes. Possible outcomes are 6. We will use the value of outcome. How many outcomes? There are 6. If the outcome is either even or divisible by 3. Even or divisible by 3, both are different things. Divide this statement into two parts, even number or means union divisible by 3. First we will assign the alphabet for event. This is the event. We will find the probability of this event, either even number or divisible by 3, then you will win the game. So suppose A is the event that the outcome is even, and B is the event outcome is divisible by 3. So this is the event. Instead of long sentence, we represent by alphabet. And how many even number? Prepare the set and find the even number 2, 4, 6. B is the divisible by 3. There are 2, 3 and 6. From this and this you can observe there is an intersection value. So intersection B is equal to 6. And question is, find the property of A or B. A or B means the game is won if either A or B or both A and B occur. Why both? Because this is a union. In union we write the member of the set A plus the member of the set B, or member of the set A and B occur both, but we write only one time. So this is the formula of the property of A union B. This is the first law. First, calculate probability of A. Number of favorable outcomes are 3, possible are 6. Probability will be equal to 3 upon 6. In this, the probability of B, 2 outcomes here, 2 upon 6. In this 1 upon 6. Simplify, you will obtain the probability of winning the game. Okay. So next time we will continue same topic and we will solve other questions.